Assalamualaikum and selamat sejahtera. In this video, we will apply the electromagnetic theory and concept in electronic and electrical engineering to our project, which is radar system. Electromagnetic waves are all around us, from radios, microwaves, TV, and even light. Electromagnetic waves were first postulated by James Clerk Maxwell and subsequently confirmed by Heinrich Hertz. Electromagnetic waves are created as a result of vibrations between an electric and magnetic field. Electromagnetic waves, or EM waves, travel with a constant velocity of 3 × 108 meters per second in vacuum. They are deflected neither by electric field nor the magnetic field. However, they are capable of showing interference or diffraction. An electromagnetic wave can travel through anything, let it be air, solid material, or vacuum. It does not need a medium to propagate or travel to one place to another. Mechanical waves like sound waves or water waves, on the other hand, need a medium to travel. EM waves are transverse waves. This means they are measured by their amplitude and wavelength. The highest point of a wave known as crest, whereas the lowest point is known as trough. Electromagnetic waves can be split into a range of frequency known as electromagnetic spectrum. Electromagnetic energy travels in waves and spans a broad spectrum from very long radio waves to very short gamma rays. Remote sensing tools such as radar and sonar allow us to map topography and surface characteristics of geological features such as planets and sea floor. Radar systems transmit a radio signal from a directional antenna. Then, the radio signal is refracted off objects that are within the transmitted beam, and a portion of the reflected energy returns to the receive antenna. Here for this project, we use an Arduino ultrasonic sensor which work by emitting sound waves at a frequency too high for humans to hear. They then wait for the sound to be reflected back, calculating distance based on the time required. This is similar to how radar measures time it takes a radio wave to return after hitting an object. The formula can be calculated as shown. Here we have all our components needed to make our radar system. We have a breadboard, a servo, an ultrasonic sensor, some jumper cables, and for our brain of the system, an Arduino Uno. Here is our assembly of the radar system. First, we supply power to the breadboard from our Arduino Uno. Then we put the signal, power in and ground to our servo. And here is our ultrasonic sensor. We first begin by sending in the signal wire to the Arduino Uno. The power, and lastly the ground cable. Finally, we can attach them together with the servo. Finally, in this section, we will show you how to program this Arduino code into our radar system. After all the coding is done, here is the initial testing of the radar system. Finally, after all the setting up is done, we can finally test out the radar system using two objects. You can see it can detect one large cup and one small toy. That is all from us. Thank you very much for your attention.